The section today is adding and subtracting polynomials, which we're going to do a little bit of that today, but really for the most part today it's going to be more really heavy on vocabulary. So I don't think section 8.1 is a lot of super difficult stuff, but it's a lot of stuff. And I used to cram all this in one day, and I was like, no, we do not need to cram this all in one day. We're going to take it slow, and we're going to split it into 2 days. So today we're going to focus more on the vocabulary, and then tomorrow we'll focus a little bit more on the adding and subtracting. So on your notes, we have some super important vocabulary. So the first vocabulary word is monomial. Okay? So for a lot of these, you may not have heard the word before, but you may know what parts of it means. So whenever you see monomial, that mono, okay, mono means one. So a monomial means one term. That nomial part refers to term. So what I mean by one term, it could be something like 4x. Now I know that there's like a 4 and an x there, but they're attached together. Okay? It could be something like x squared, one term. Or it could be something like x squared y cubed, one term. Now, whenever we're talking about this word term, terms are separated by addition and subtraction. So if you don't see addition and subtraction, 4x, that's just one term. Now if it said 4 plus x, that would be different, because 4 plus x, that would be two terms. Okay, terms are separated by addition or subtraction. Okay, so that kind of brings us into our next vocabulary word, which is polynomial. So notice the nomial part is the same. Poly means many. So instead of one term, it's many terms. So a polynomial is a monomial or sum of monomial. It just means it's more than one term. So for example, it could be like 3x squared plus 4x minus 2. This would be an example of a polynomial. I have three terms here. So to separate out the terms to show it to you, 3x squared is one term, plus 4x is another term, minus 2 is a third term. There's three terms there. Many terms is a polynomial. Now, one of the things we're going to kind of start talking about today, we'll focus a little more on it tomorrow, is this idea of like terms. We've talked about this a little bit so far this year. Whenever we talk about like terms this year, it's kind of been like an x and an x is like terms, a y and a y is like terms, x and y are not like terms. So it's kind of that same idea, just extending it a step further. So if something is going to be like terms, they are going to have the same variable part. And the big thing here, the variable part has to match exactly. So if I want to look at an example of like terms, if I'm talking about 6x, anything that's a like term with 6x has to have the exact same variable part. It needs to be an x. So it could be like 6x and negative 3x. They're both x's. But it could be something a little bigger, like maybe negative x cubed y and 4x cubed y. It doesn't matter what the coefficient is, what the number in front is. If they're like terms, all you have to look at is the variable part. Notice they're both x cubed y. It should match exactly. Okay, now one of the things we're going to talk about today is we're going to talk about the degree of a monomial and the degree of a polynomial. Okay, so let's start here with the degree of a monomial. This is super, super simple to do. I think it sounds more complicated than it is. You're going to take the sum of the exponents of the variables. The sum means add. So we're going to add the exponents of the variables. So if I had like 14x cubed y squared, 14x cubed y squared. If I wanted to find the degree of that monomial, I would add the exponents of the variables. So in this case, I would just take 3 plus 2. This would be a fifth degree. A fifth degree. Now, if you want to find the degree of a polynomial, this sounds even more confusing, but it's actually even simpler. To find the degree of a polynomial, it is going to be the same as the degree of the monomial with the greatest exponent. Okay? To make this simple, you are going to look for the term that has the largest exponent. Okay? The degree of that term, like what we did up here, is the degree of your polynomial. So if I had like negative 4x squared plus 8x to the 4th plus 5. To find the degree of the polynomial, you're going to find the term that has the biggest exponent, which would be this middle one, right? The 8x to the 4th. So you would find the degree of 8x to the 4th. That's the degree of the polynomial. So to find the degree of a monomial, which is what we would be doing, you'd add the exponents of the variables of just that term. Now this just has one variable, it's just an x, which is just a 4th. So since this monomial is the 4th degree, this polynomial is the 4th degree. So if it's just a monomial, it's just one term, you're adding all of the exponents. If you're finding the degree of a polynomial, you're just finding the biggest term, right? The term with the biggest exponent, and just looking at its exponents. Okay? And then the last thing, and this is going to be super relevant as we move forward through this chapter, we're going to really want to get in the habit of writing things in what's called standard form. I've mentioned it before, but we really want to start doing this here. So if something's written in standard form, the degrees of the monomials decrease from left to right. The degrees decrease from left to right. Now, most of the time when we're talking about degrees of a monomial, usually, I know in this example we had an x and a y. Usually you're just going to have just an x or just a y. So what you're going to do, for the most part, you're going to write your exponents from biggest to smallest. So if I had like negative 4x plus 5 plus 3x squared. Okay, if I wanted to write that in standard form, you find your biggest exponent, okay, which is going to be this 3x squared. You're going to write that first. Now, whenever you're rearranging these, keep in mind that the sign in front of the term is the sign that goes with it. So this is a positive 3x squared. Okay, after the x squared would come the x. Now notice this is a negative 4x, so I'm going to say minus 4x. And then we're going to do the plus 5. That would be the standard form of that polynomial. Okay, now, one of the things you're going to be doing today is you're going to talk about how we can name specific polynomials. So there's two ways that you can name a polynomial, okay? You can name a polynomial based off its degree. You can also name a polynomial based off how many terms it has. So we're going to go through a couple of these examples here. So let's start here by looking at a polynomial, super simple, 3. Remember, a polynomial is a monomial or a sum of monomials. Okay, so this is just 3. That's it. Now, if I wanted to find the degree, okay, remember, the degree is the sum of the exponents of the variables. But I don't have a variable. So if I don't have a variable, keep in mind that if I had a variable, even if, and don't write this down, but even if this was just an x, right, that would be different, right? But if this was an x to the 0, what is anything to the 0 power? 1, right? So the x wouldn't be there, okay? So anytime you don't have a variable, the degree is 0. And the name for anything to the 0 degree, or anything that doesn't have a variable, is called a constant. Because think about it, that 3 is constantly going to be a 3. It's always going to be a 3. It's never going to be anything other than a 3. It's going to stay constant. Now that 3, that's just one term. That's it. We already know what a polynomial with one term is. It is a monomial. A monomial. we have, let's say we're looking at 4x minus 3. Now to find the degree, you're going to find the monomial with the largest exponent, which this one is just the x. Okay, so we're looking at 4x. I need to find the degree of 4x. So I need to know the exponents, the sum of the exponents of the variables. I don't see an exponent. If you don't see an exponent, what is it? It's a 1. So since the degree of 4x is 1, the degree of my polynomial is 1. Now anything to the first degree is linear, which makes sense. Because anytime we had a linear function, the x was just an x, okay? Linear. Now this one, 4x minus 3, this has 2 terms. Anything with 2 terms is called a binomial. Binomial. Okay, next one. So we have x squared minus 3x plus 4. Now to find the degree, remember you're looking for the largest exponent, which here is the 2. You're just looking at the x squared. To find the degree of the polynomial, I need the degree of x squared. What's the degree of x squared? 2, yeah. So it's usually going to be the exponent. Now anything to the second degree is called a quadratic. Anything to the second degree is called a quadratic. And for the number of terms, I have x squared minus 3x plus 4. I have 3 terms, which is called, any guesses? What? We have mono, bi, what's 3? Tri, yeah. It's a trinomial. A trinomial. Okay, what if we look at 6x cubed? 6x cubed. Now the degree of 6x cubed, you're going to look for the monomial that has the highest term. This is just one term anyway, so I'm just looking at the 6x cubed. What is the degree of 6x cubed? 3, yeah, 3. Anything to the third degree is called a cubic. Cubic. And how many terms is this? Just one, which is called a? Yeah, we already did that one. Monomial. Okay, and then the last one here. What if I have x to the 4th minus 3x squared plus 5? Now to find the degree, look for your highest exponent, which is the 4. So the degree of x to the 4th, what would the degree of x to the 4th be? 4, yep. Now, anything higher than a 3, anything to the 4th degree, 5th degree, anything like that, there's no special name for it. It's just called the 4th degree. If it was a 5, it'd be a 5th degree. Okay, how many terms does that one have? 3. X to the 4th minus 3x squared plus 5. 3 terms, which is called a trinomial. Now, anything with more than 3 terms, I think there's one in your homework that maybe has 4 terms. We just call that a polynomial. There's not a special name for anything above 3. Okay? Questions on that? Okay, we are in a new chapter. So we need a new table of contents. So your next open page should be page 11. That's going to be your table of contents, which means page 13 is going to be section 8.1, adding and subtracting polynomials. Adding and subtracting polynomials. Alright, so we're going to do 3 things today. Find the degree of a monomial, we're going to simplify it, and then find the degree of a polynomial, and then on from there. So these first ones, super incredibly easy, or should be. So to find the degree of a monomial, remember monomial is just one term. So if you're just looking at one term, you're adding the exponents of the variables. So if I have 8a cubed, you're adding the exponents of the variables. If I just have one variable, that's your degree right there. This is going to be the 3rd degree. So its degree is 3. Okay, number 2, if I have 2a to the 8b squared. 2a to the 8b squared. So to find the degree of a monomial, you're adding the exponents of the variables. So for this one, you would take 8 plus 2, so this degree would be 10. Okay, number 3. What if I have negative 3? Now we talked about this one. If I add the exponents of the variables, but if there's not a variable, it's 0. Yep, and didn't ask for it, but this is called a constant. And number 4, what if I do 18x cubed y? Be careful on this one. So if you add the exponents of the variables, I see that exponent, but I have 2 variables here. I have the x and the y. What's the exponent on the y? A 1. So don't forget to take 3 plus 1. Its degree is 4. Okay, so we're going to do a little more of this tomorrow, but we're going to kind of introduce it today. So we're going to talk about simplifying. Let's say we have 3t to the 4th plus t to the 4th. Now, we've mentioned this before, and I think it just gets really difficult or really tricky because we just got done talking about exponent rules. Okay? But keep in mind, with a lot of the exponent rules that we were doing, we were multiplying. If you remember me saying that a couple times in the last chapter, I was always saying, this times it's just a big multiplication problem. But that's not what's happening here. This is adding. So when you're adding, what I encourage you to do is try not to think about it as math. Think about it as things. Okay? 3t to the 4th means you have 3 t to the 4ths. I don't know what a t to the 4th is, and it doesn't really matter, but you have 3 of them. Okay? And with the other t to the 4th, it's just a t to the 4th or a 1 t to the 4th. So think about it as a thing, not as math. You have 3 t to the 4ths and another t to the 4th. How many do you have? 4 t to the 4ths. Okay? What gets confusing here, the variable part does not change. Just like if you said, okay, I have 3 apples and 1 apples, and I'm going to put them in the same pile, I have 4 apples. Right? You're adding them together, right? And they're still apples. The apple part doesn't change. Just how many you have does. The variable part does not change when you are adding and subtracting. That's super important. Let's try another one of those. Okay, let's do 2m cubed n cubed plus 9m cubed n cubed. I guess one thing I should have mentioned on the last one, shouldn't be an issue today, but you can only combine them together if they're like terms. So notice this one, the t to the 4th and t to the 4th are the same thing, right? So here I have 2m cubed n cubes and 9m cubed n cubes. And I don't know what an m cubed is, but these m cubed n cubes and these m cubed n cubes, they're the same thing. They're like terms. So if you have 2 of them over here and 9 of them over here, if you add them together, how many would you have? 11 what? M cubed n cubed. That's kind of a hard word to say there, isn't it? So what you're doing, you're adding the coefficients, keeping the variable part. Let's try one more of those. Okay, number 7. 5bc to the 4th minus 13bc to the 4th. So really the first thing you should do is decide if you can combine these together. Are these like terms? Yeah, because they're both bc to the 4th, right? So think about what we did over here. We did 2 plus 9. Over there we did 3 plus 1. You're going to do the same thing here. You're going to take 5 minus 13, which gives you negative 8. And the variable part stays the same. Negative 8, bc to the 4th. Any questions on those ones? We're going to keep those pretty simple today. Okay, the last thing we're going to do, we are going to look at a polynomial. We're going to write it in standard form, which basically means you're going to write the exponents in decreasing order. And then we're going to name it two ways. Now, where these names come from, in this table over here, which you're probably going to want to keep this handy for your homework, you're going to name it using one of these words. You're going to name it using its degree, and you're going to name it using one of these words. Name it using its number of terms. So you're going to use one name from here and one name from here. So we'll come back to this. Let's look first at number 8. It says 7 minus 2q. Now, first of all, we want to write it in standard form. Now, if it's in standard form, the big thing with standard form, okay, the degrees of the monomials need to go in decreasing order. So you need to find your highest powered term first. So in this case, that's 7, because there's two terms here, okay? What's the degree if it's just a 7? 0. It's always going to be 0. Anytime there's not a variable attached to it, it's always going to be 0. That needs to go at the end. Always is going to go at the end. And the degree of negative 2q is going to be a 1. So what I do is I just need to kind of switch these around. Remember, the sign in front is the sign that travels with it. So the 2q is actually a negative 2q. The 7 is a plus 7. So that's the first thing you would do is write it in standard form. Now, I want to name it based on its degree. Now remember, the degree of the polynomial, you are just looking, if it's in standard form, you're just looking at the first term. Okay, so that first term, what did we say the degree of negative 2q is? 1. Now, here's what you're going to do is you're going to go back to your chart. If it has a degree of 1, it's linear. So that's the first way that you're going to name it. It is linear. Then you're going to name it based on its number of terms. How many terms do I have? 2. Negative 2q plus 7. So you're going to go back to your table. Anything that has number of terms, see it? Number of terms, 2 is a binomial. So this is a linear binomial. Okay, let's try another one. Number 9. 3z to the 4th minus 5z minus 2z squared. Okay, first thing, we want to write it in standard form, which means the highest power needs to come first, which it already is, but then they need to be in decreasing order, which isn't quite true, right? I need to flip these around. So we're going to do the 3z to the 4th. Remember, it's carry the signs with them. This is a negative 2z squared and a minus 5z. That's the first thing, write it in standard form. Now we're going to name it based on its degree. So remember, once you write it in standard form, to find the degree of the polynomial, just look at the first term, 3z to the 4th. What's the degree of 3z to the 4th? 4, yeah. So you're going to go back to your table. So the degree is 4. So remember, anything above 3, you're just going to call it a 4th degree. If it was a 5, you'd call it a 5th degree. So we're going to call this a 4th degree. And then to name it based on its number of terms, how many terms do I have here? 3. 1, 2, 3. So go back to your table. The number of terms, it has 3 terms, so it is a trinomial. Yeah, very good. A 4th degree trinomial. Okay, let's do one more. Okay, number 10. 4q squared plus 3q plus 6q squared. Now, first thing, we want to write it in standard form, okay, which means my squared term needs to be written first, which is partially true. But what's different about this one? So I've got a 4q squared and a 6q squared. That's it. That's a thought. So the 6 might go first because it's bigger. What do you know about 4q squared and 6q squared? What could I call them? From maybe what? You can combine them. Yeah, sorry. Yeah, you can combine them, right? Because they're like terms. So we want to go ahead and do that. 4q squared plus 6q squared is 10q squared. Remember, there's still q squareds. There's just 10 of them. So if you can combine them, if you can simplify them, you want to go ahead and do that. So I have 10q squared plus 3q. Now to find the degree, we're going to look at 10q squared. What's the degree of 10q squared? 2, which means I would call it a what? Quadratic. And how many terms do I have? 2. How many? Oh, sorry. Go to your simplified answer. There's 2, which is called a binomial. Yeah, make sure you're using that chart if you need it.